last video, graphing the sine curve, we talked about what the period was and what the general sine curve looked like. The general sine curve being y is equal to sine of x. Well, in this video, we're going to talk about transformation of that. For example, this graph, y equals 3 sine of 2x. It has a number in front of sine, and you have a number in front of x. Unlike this one, you had only 1 here and only a 1 there. So if that's the case, now we have transformation. There's been a shift, there's been a change in the graph. So basically the number in front of x, in this case 3, we call it A, and that represents your amplitude. Amplitude is the absolute value of A. Whatever that number is in front of sine, you get the positive version of it, and that's going to be the A value. So amplitude, if you're looking at any graph, amplitude tells you how high and how low that graph goes from the middle. So if this was the middle, my amplitude would tell me it went up 3 and it went down 3. So that tells me that length. So that means that in this graph, it went up to the number 3 and down to the number -3. So that would be the whole graph's range. It would be all the numbers in between -3 and 3 for y. We have no numbers outside that range. So that's what the amplitude is. It tells you how high and how low it goes from the middle of the curve. The next thing is period. The period for the sine curve is always 2 pi divided by b. So the b value, again, is the number in front of x. In this case, in this problem, we don't have any addition and subtraction going on here. So that means there is no c value. Had we had a number been added or subtracted, for example, y is equal to sine of 2x subtract 8. Well, in this case, this 8 would be our c value, and this would be our b value, and 1 would be our a value. So, but in this problem, we don't have a c. But our period is 2 pi over b. The c value, you have to find our phase shift, our horizontal shift. Sometimes the horizontal shift, and they write it as phase shift. Exact same thing as horizontal shift. Depends on what book you're looking at. So it's the exact same thing. But anyway, the horizontal shift is -c over b. Increments, basically the increments are all of the important numbers. If you graph the sine curve, it looks like this, and you have important places other than the origin. So it starts here, but here is an important place because that's where it maxes out. Here's an important place because it's an intercept. There's another important point because that's where it bottoms out. This is the last important point because that's where it ends. So each one of those will represent increments because each one represents a different thing that the curve is actually doing. So typically we'll have 4 of those. Then you have your starting point, which would actually be here. So phase shift, horizontal shift, and we can call it starting point. All those are representing the exact same thing and tell you where your graph begins. So anyway, enough talking about it, now let's actually use it. If you actually graph this equation, y equals 3 sine of 2x, you first find amplitude, and amplitude is the amplitude value of 3, so it's 3. The period is 2 pi over b, so it's 2 pi over 2, or just pi. The horizontal shift is -c over b. Because this has no c value, it's technically 0. The reason why is that's really 3 sine 2x subtract 0. Because 2x subtract 0 is 2x. So it means the c value must be 0. So if that's the case, it should be -0 over 2. Well, -0 is 0. Anything divided into 0 is 0. So my horizontal shift is 0. Horizontal shift is 0. Last thing is increments. Increments of period is the period divided by 4. So it's going to be pi over 4 are your increments. So now we're ready to graph it. So the first thing you graph is your starting point, or your horizontal shift. Since that's at 0, my first number here I'm going to graph here is 0. Next thing I look at is amplitude. my amplitude is 3. From that starting point, I'm going to go up 3, I'm going to go down 3. So you can mark it off if you want, or you can go up to number 3 and down to number 3. The next thing you want to graph is the increments. So since my increments are pi over 4, every number outward is going to be pi over 4 from the last. So this would be 1 pi over 4. If you add pi over 4 to it, your next number would be 2 pi over 4. If you add pi over 4 to that, you would get 3 pi over 4. And if you add pi over 4 to that, you get 4 pi over 4. Now, some of these numbers reduce. For example, 2 pi over 4 actually reduces to be pi over 2. And 4 pi over 4 actually reduces to be pi. So it's nice to know that if you want to rewrite those as what they reduce to be, that's fine. I'm going to leave it as 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Because it's just easier to count off whether you have the period correct or not. So from there, when we actually graph the curve, you would start it at the starting point. The next point over is a maximum. The next point is an intercept. The next point is a minimum. And the next place is the finishing point, another intercept. So the graph looks like this. It goes up through that point, goes down through this one, comes back through, and it finishes there. So that's one period of the sine curve. If you take a look at it, the period is pi. It takes pi units to actually begin and end. So after this, it will go back this direction, do the same thing, and it will continue on doing the same thing in that direction. But more importantly, one period gives you one cycle of the curve, one wavelength. So that's our period. If you also take a close look, we made it so that our amplitude is 3 up and went 3 below. So that's our amplitude for that curve. And that is that curve. That's what that curve looks like. If you graph from the calculator, it should look just like that. So in this one, we're going to graph it. So right now, pause the video, find the value of the amplitude, find the value of the period, find the value of the horizontal shift or starting point, find the increments. Take a minute right now to do that. Should have found amplitude to be absolute value of A, which is absolute value of -2, and that's 2. Should have found the period to be 2 pi over B. In this case, B is this. So it's going to be 2 pi divided by the number in front here. It's 1 over 4. So the B value is 1/4. So it's 2 pi divided by 1/4. You divide that fraction into a whole number, you wind up getting 8 pi. And the reason why you multiply by the reciprocal, just equal to U, 2 pi divided by 1/4. Same thing as 2 pi divided by 4. So that means 2 pi times 4 over 1, or 8 pi. Because you put this over 1 and you multiply. So that's the reason why it's 8 pi. I'm sure you already knew that, but if you didn't, that's the reason why it's 8 pi. Horizontal shift is -C over B. Here is C. So it should be -3 divided by 1/4. It makes it positive 3 over 1/4. And if you guess, it's going to be 12. So your horizontal shift is positive 12. Increments is the period divided by 4. Since your period we found earlier to be 8 pi, it's going to be 8 pi divided by 4. It's 2 pi. So each increment is 2 pi from the last. So now let's graph this. First thing we start with is our horizontal shift. Again, same thing as a starting point. Starting point is 12. So my first point is going to be here. I'm going to say 12 is right there. And then the next thing is the amplitude. So I know I go up 2, I go down to -2. And the next thing is the increments. So I know my increments are 2 pi from the last. So if that's the case, this is what it looks like. If my starting point is here at 12, I have to go 2 pi from it. And you may know that number is 12 plus 2 pi. So basically I'm gonna add 2 pi to it. So the next number would be 12 plus 4 pi. Then I'll add 2 pi again, and that would be 12 plus 6 pi. And the last one would be here, and that would be 12 plus 8 pi. Since that wasn't really equally spaced, like this space and that space and that space, all they look to be about the same. Move it over here. It's gonna be 12 plus 6 pi. And then this is about right here, 12 plus 8 pi. Will be the last one. So from there we can graph it. My starting point is here. I should go up. I should max out here. I should have an intercept there. I should have a minimum at -2. Now I should have an intercept there. So the graph looks like this. So that's one period of the sine curve. From here to here has a period of 8 pi, which is actually really, really big. So that's a long distance, considering the average one has only a period of 2 pi. But that's what it is. It's a very, very wide sine curve with an amplitude of 2. And that's it.